rotating thing to grow.
You have one left now. One try out. Back to level 1.
Can't play original level devil. Play the original level devil, trust me. You will not sleep.
Guy,
I played Geometry Dash, oh.
Level devil
Dash. Have you played MDC? What did they call
So
this game?
that beautiful suffering you just watched is my fault, entirely on purpose. If you don't know Level Devil, it's this deceptively cute little platformer where literally every surface wants you dead. Fake floors, saws, walls that just decide to become your problem. It's a mobile game that lives on people's phones, minding its own business. I decided that wasn't enough. I didn't just want to play Level Devil, I wanted to hold it physically in my hands. So I built my own version on an ESP32 with a real screen, real buttons, and because apparently regular Level Devil wasn't cruel enough, I added my own extra hard levels on top of it. For anyone who's never seen the original, here is it. This is the game that inspired the chaos. Watch how innocent it looks.
Now, if you ask me why I created this game, I have no idea.
Honestly, because everyone keeps using ESP32 boards for normal things. Temperature sensors, home automation, smart devices, useful projects. Boring. I wanted to see if I could turn a tiny microcontroller into something that actively ruins people's day. Also, game development on embedded hardware teaches a surprising amount about optimization. On a computer, if your code is inefficient, your PC just silently suffers. On a microcontroller, it crashes publicly and humiliates you. So this project became a challenge. Can I recreate a frustrating platform game on hardware that costs less than a pizza? Now let's talk parts, because none of this works without them. For the display, I'm running a 240 by 320 SPI TFT display driven in landscape. The brain of the whole operation is an ESP32S3. It's small, it's fast enough, and it's got more than enough pins I need for this project. And for the authentic crunchy 8-bit death sound, a passive buzzer. It's not going to win a Grammy, but when you die, and you will die, it screams at exactly the frequency needed to make you feel something. Input wise, 4 push button, left, right, jump, and select. Select doubles as pause button. Now the part everyone either loves or immediately tunes out for: wiring. Buttons first, all wired input pull up, so each one just needs a leg to the ground. Left to GPIO 4, right to GPIO 5, jump to GPIO 6, select to GPIO 15, buzzers on GPIO 16. For the display, SPI handles communication, which is basically the ESP32 screaming pixel instructions really fast. MOSI GPIO 11, SCLK GPIO 12, CS GPIO 10, DC GPIO 9, Reset GPIO 8, and the backlight, which is also known as the LED or LED, GPIO 7.
Now, if you ask me why I created this game, I have no idea. For the fun of it.
Yeah, coding time. I know for some of you this part can be very boring, and this is the part where you go and check how much of the video is left. Stick with me, I'll keep this short so you don't hate me. The very top of the sketch is just naming things, so future me doesn't have to remember that GPIO 6 is jump 6 months from now. Every button gets assigned to a GPIO pin, the buzzer gets a pin, the display gets initialized. Nothing exciting. Boring? Yes. Necessary? Also yes. Now this part just define and states this or that. Nah. Let's get to the important stuff. There's one function that does all the dirty work. Trigger death. You can find it here. You can find it here again. Here again. See? Trigger death. That's it. That's the entire you have failed pipeline. The interesting part is who is allowed to call it. I went through and counted. There are 4 completely different ways this game ends you. Number 1, spike platforms. Number 2, falling off the level. Number 3, hazards. Number 4, and my personal favorite, the crusher platform. Now you understand the full code. I will go on to upload. Click on tools, click on boards to select your boards, and then your port. A very important step is making sure this, and this are enabled and correctly configured. With that said, hit upload. But we've missed one important step, and that's the user setup.h code in the Arduino library. Now, if you are using TFT SPI, you've probably experienced this. You upload your code, the display is blank or upside down, or the colors look like they've been through a washing machine. The fix lives inside your user setup.h. This file tells the library what display driver you are using, the screen resolution, the SPI pins, and how fast the display communicates. Without this file configured correctly, nothing works. Now, these are the pin definitions. If you notice this very well, it corresponds with our wiring. Match this file to your actual wiring every single time you change boards or pin. And that's a wrap for coding. I trust I didn't bore you. Go ahead and upload. All links to both codes will be in the description and comment section of this video for free. So you may be asking, what does level 2 look like? You've always failed at level 1. Well, shade seen and collected. After everything, after every crusher, every fake door, every spike strip I lovingly placed myself, I want to show you the one time I actually beat level 1 and made it into level 2. This is not a reenactment. Yes. Level 2 introduces more chaos, moving saws, patrolling missiles, walls that chase you. The ESP32 is now rendering all of this in real time while pretending to be a game console. And surprisingly, it actually handles it really well, which says a lot about how powerful these tiny bots have become. And then, obviously, it all fell apart again. But that's kind of the whole point, isn't it? So what did we learn? An ESP32 can absolutely run surprisingly complex games. That is if you optimize it very well. In the end, every player reached the same screen, the screen that perfectly summarizes this entire project. You died. And honestly, that's exactly what I was aiming for. I'll leave the code linked below if you want to build your own suffering machine. Subscribe and like for more.